Okay, this is the fourth grade. Right, this is the homework check for the fourth grade working on the Q3 material. And we're going to start with, we have been starting with the bottom, our new stuff first. So we're going to do that today too. Let's take a look at the very last one. Okay, half of 6 is, I think that's pretty obvious, right? Half of 6 is 3. But what is 6 times a half? Okay, we're going to show that a little bit differently. I'm going to change each of these to show halves. And if I don't do it perfectly, why, you get the gist. But when I'm done, I will have 6 halves. Do you see that? I'm coloring in halves, and I have 6 of them. But what I can do is combine my halves. So I could take this one and put it up here and make that into a whole. That means I get to erase this one now. All right, I'm going to take this half and put it up here. Okay. And I'm going to take this half and put it up here with this one. And you can see, either way we look at it, if we have talking about half of a group of 6 or 6 actual halves, we end up with how many wholes both times? 3. So remember, the way we've been doing this, 1/2 of 6 is we change the of to a multiplication sign. We change the 6 to 6 over 1. We multiply across. 1 times 6 is 6. And 2 times 1 is 2. And this means 6 divided by 2. That means 6 divided in half is 3. All right, now let's move to the top. Doing some rounding. Okay, we're going to use this number 3 different times. The first way, we're going to round to the nearest 100. So what I get to do is copy down everything but stop when I get to the underlined one. So we look at the digit to the right. The 2 tells us what to do to the 8. Our choices are go up or stay the same. 2 is not high enough to make it go up, so the 8 stays the same. And this circle is to remind me to make zeros from this point on. Okay? Now, let's use that same number. But this time we're going to round to the thousands place. So that's the 3. We circle the digit to the right. I can go ahead and write down every digit, but stop when I get to the underlined one because it might change. The 8 tells us what to do to the 3. Our choices are go up or stay the same. The 8 is higher than 5, so we get to go up. The 3 goes up to a 4. And this circled part reminds me to make zeros from everything to the right. Okay, now we're going to do the same number to the nearest 10,000s place. So 10,000s is right here. Circle the digit to the right. We can copy down the 5. Then we have to stop. Is the 3 high enough to round the 4 up? No, it's not. So this circled digit reminds me to make everything else into zeros. So 540,000. Okay, moving to the next one. Find the difference. 28,547 minus 8,759. Here we go. 7 minus 9, we have to borrow. 17 minus 9 is 8. 3 minus 5, we have to borrow. 13 minus 5 is 8. 4 minus 7, we have to borrow. 14 minus 7 is 7. 7 minus 8, let's borrow again. 17 minus 8 is 9. And bring down the 1. 19,788. Okay, dividend divided by the divisor equals the quotient. Okay, and we're making groups of 8. So we're going to stretch out our dividend here and leave a space in between each digit. All right, and draw our lines right behind the digits. We're making groups of 8. How many groups of 8 can we get out of 8? Why, just one group of 8, and 1 times 8 is 8. We subtract. The leftovers come up here, but since we're going to be consistent, we're going to keep doing it even if it's a 0. How many groups of 8 can you get out of 2? You can't get a single group. 0 times 8 is 0. Subtract, you get 2. Let's bring the leftovers up. Now we're looking at 27. How many groups of 8 can we get out of 27? 3, because 3 times 8 is 24. That gives us a difference of 3. The leftovers pop right up. How many groups of 8 can we get out of 35? 4, because 4 times 8 is 32. And look, when we subtract, we've got leftovers right here. This is our remainder. It's what's remaining. That's why it's called a remainder. So we do R3. So final answer is right up here. I'm going to write it underneath now. 1,034, remainder of 3. All right, there are 35 rows in the stadium with 896 seats in each row. You see, because they're really big rows. How many seats are there altogether in the stadium? Well, we could add up 896 35 times, but that'd be pretty ridiculous. So let's do 896, and we're going to break this 35 apart into 30 and 5, and we're going to do 2 problems. So here are our 2 problems. Drop down your 0. 3 times 6 is 18. 3 times 9 is 27, plus 1 is 28. 3 times 8 is 24, plus 2 is 26. So this is our partial product. That's why this strategy is called partial product. We get part of our answers, then we add up the parts. Okay, 5 times 6 is 30. 5 times 9 is 45, plus 3 is 48. 5 times 8 is 40, plus 4 is 44. All right, so now we're going to take these two, 26,880 plus 4,480, and we're going to add them. 0 and 0, 0. 2 8s is 16. 8 and 4 is 12, plus 1 is 13. 6 and 4 is 10, plus 1 is 11. And 2 and 1 is 3. And I should not have circled these, because I want you to do that to your final answer. It just makes it easier to see what the final answer is. But we need a word. How many seats? 31,360 seats. Okay, create a pattern with the rule n times 2 plus 1. So we're going to start with n being a 1. So 1 times 2 is 2, plus 1 is 3. Now we'll pretend that it's the 2. 2 times 2 is 4, plus 1 is 5. 3 times 2 is 6, plus 1 is 7. 4 times 2 is 8, plus 1 is 9. And 10 times 2 is 20, plus 1 is 21. And there you have it. Now you might be tempted in finding patterns to just look at the difference between these and say the rule was plus 2, but that's not true, because on the very first case, we call this case 1, case 2, case 3, case 4, case 10. And on the first case, that appears to work, because 1 plus 2 is 3. But then with the second case, if you test the plus 2, it doesn't work, does it? So be careful. You've got to apply the rule all the way down the cases, okay? Find an equivalent fraction. One way that we do that is we double both numbers. So double 4 is 8, double 7 is 14. Another way we do it is if we can have both of the numbers. And there are more ways to find equivalent fractions, but these are the first 2 ways we're learning. Half of 6 is 3, and half of 12 is 6. And even this will continue on. Do you notice that if you have 3 out of 6, watch this, if we divide this into 3 parts, and we color in 6 of them, do you see what that's also equivalent to? It's equivalent to 1/2. Now what we ended up doing there was 3 divided by 3 equals 1, and 6 divided by 3 equals 2. The rule for making equivalent fractions is whatever you do to the top, you have to do to the bottom. You can multiply or divide, but you have to do the same thing to the numerator that you do to the denominator. And on that case, we divided by 3. All right, adding and subtracting our mixed numbers. We know we start with the fractions first. 7 plus 3, 7/8 plus 3/8 is 10/8. 2 plus 2 is 4. But we can't leave it like this. It's just not proper to have the numerator be larger than the denominator. That means you can pull another whole out, sometimes more than one whole. But with 8s, we're going to pull out 8/8 and give it to the 4 side, so we don't have 4 wholes anymore. We have 5. And if I take 8/8 from the 10/8, that leaves us with 2/8. Now let's do our trick though, because this is not reduced. Okay, it's not in the simplest form that it could be in, the easiest form to understand. So let's go ahead and bring over our wholes, which is 5. Now we're going to half the 2. Half of 2 is 1. Half of 8 is 4. And we can't go any farther. Now on to the subtraction. We have to start with the fractions. And 1/4 minus 3/4. Oh goodness, we don't have enough. So we have to go and borrow a whole. Okay, we're going to borrow that whole from the 3. So now we just have 2 wholes. But the whole that we borrowed was really 4/4. And we're going to combine it with the 1/4 that we already have. So 4/4 plus 1/4 would give us 5/4 now. And now we can subtract. 5 minus 3 is 2, so that's 2/4. 2 minus 1 is 1. Now look, this is not reduced, okay? Let's bring over our 1 and let's reduce this fraction. Half of 2 is 1. Half of 4 is 2. So the best way to say it is 1 1/2. All right, Mary's house is 3/4 of a mile from Carrie's house. Carrie's house is 1/4 of a mile from Gina's house. How far is it from Mary's house to Gina's house? So I like to draw little houses. All right. So we're going to do Mary's first. I'll put an M for Mary. And then it is 3/4 of a mile all the way to Carrie's house. I'll put a K. There's Carrie's house. And then Carrie's house is 1/4 of a mile from Gina's house. So this is what it actually looks like, okay? How far is it from Mary's house all the way to Gina's house? We need to add these two. So 3/4 plus 1/4. 3/4 plus 1/4 is 4/4, and that is the same as 1 whole, and it's 1 whole mile is the final answer. And that's it for today.